Ever scrolled through like real estate listings online and just wondered how do they get those prices? Like obviously a bigger house is going to cost more, but
Yeah.
like how do they actually figure out how much more?
Yeah, it's a fascinating mix of art and science, really, but there is a powerful mathematical tool that plays a huge role, and that's called linear regression.
Linear regression. Okay.
Yeah.
I'm intrigued, but math and we don't always get along. So
Yeah.
but can you break it down? Like what's the main idea here?
Sure. So at its heart, linear regression is all about finding relationships in data. So just imagine like plotting all these different houses on a graph, square footage on one axis, price on the other. And then linear regression is basically like drawing a line through those points, trying to kind of like capture the overall trend.
Okay, so we're drawing a line to show how house size and price are connected.
Yeah.
Got it. But like, couldn't you draw a ton of different lines through those points? What makes one line better than another?
That's where the science part really comes in. We're not just aiming for any line. We want the one that fits the data the best, the one that minimizes the difference between the prices our line predicts and what the houses actually cost.
So we're trying to minimize how wrong our predictions are, basically, like get that line as close as possible to all the real data points.
Exactly. The closer our line is to those real-world prices, the more accurate it is as a predictive tool. And there's a mathematical way to actually measure that accuracy. It's called a cost function.
Cost function, huh? Sounds intense.
It's really just a way to calculate the total error of our line, the difference between our predicted prices and the actual prices. Think of it kind of like aiming at a target every time we miss the bullseye. It's like our predicted price missed the actual price. So the cost function tells us overall how far off we are.
So like the lower the cost, the better our line is at predicting those house prices.
Right. Exactly. And the process of actually finding that best fit line, the one with the lowest possible cost, that's where things get really interesting. And that's where we use this technique, gradient descent.
Gradient descent. Okay. Now you're really taking me back to high school math class. Is
Yeah.
this where it all goes over my head?
No worries. It's not as complicated as it sounds. Just imagine trying to find the lowest point in a valley like you're hiking. So gradient descent is basically a way to step-by-step guide us down the slope of that cost function we talked about, gradually adjusting our line until we reach the bottom. That's the point where our error is as small as possible.
So it's like a systematic way to find that best line without just like randomly trying a zillion different ones.
Exactly. It helps us zero in on that line that gives us the most accurate predictions based on the data we have.
So gradient descent, that's our like GPS getting us to that best fit line. But I'm still a little lost on how we actually represent that line, like mathematically.
You're right. We've been talking about it kind of conceptually, but there's a really simple equation that's at the heart of all of this. Remember back in algebra class, y equals mx plus b?
Vaguely. Something about
Okay.
slope and y-intercept,
Yeah.
right?
Exactly. And in linear regression, we use a very similar equation. It's h of x equals theta 0 plus theta 1 times x1. So h of x, that's our predicted value. Theta 0 is kind of like the y-intercept, and theta 1 is like the slope representing how house size, which is x1, relates to the price.
So instead of y and m, we have h of x and theta 1, but it's still basically just a line equation.
Precisely. And those theta values, those are what we're trying to optimize with gradient descent.
Yeah.
Remember, by adjusting those values, we're basically tweaking like the position and the slant of our line to find that perfect fit.
Okay, so finding the right values for the 0 and theta 1, that's the key to getting those accurate predictions.
Exactly. And remember, our cost function, well, it helps us figure out how good our current theta values are. Gradient descent basically just nudges those values little by little, always trying to minimize the cost until we find that magic combination that gives us the most accurate predictions.
So it's like we're fine-tuning the knobs on our prediction machine, and that cost function, that's our guide, telling us if we're getting warmer or colder.
That's a great way to think about it. And the cool thing is this approach, it scales really well. Like,
Well,
what if we wanted to consider more than just the size of the house? Things like how many bedrooms it has or even what neighborhood it's in.
wait, so you can factor in multiple things at once. How does that work?
The main idea stays the same. Our equation just gets a little longer. We add more thetas, one for each new factor we want to consider, and each of them influences that final predicted price.
So instead of just square footage, our prediction could take into account square footage, number of bedrooms, lot size, all at the same time.
Exactly. Each of those factors would have its own theta value, showing how much it impacts the price and gradient descent that would help us find the optimal values for all of them at the same time, creating this like multi-dimensional model.
My brain's starting to hurt a little bit, but in a good way. It's just amazing how we can capture these complex relationships with what seems like a pretty simple equation.
It is pretty elegant, and this flexibility is what makes linear regression so powerful. It can be applied to a ton of different problems, helping us uncover those hidden connections in data and make smarter decisions.
Okay, so we've got this powerful tool, juggling all these variables, finding hidden connections and making predictions. But I'm curious, like, where do we actually use linear regression, like out in the real world?
Oh, the applications are incredibly diverse. Take finance, for instance. Linear regression. It plays a big role in stock market analysis, like helping to identify trends and, make those predictions about how things are going to perform in the future.
So instead of predicting house prices, we could be predicting STIP prices. And what kind of factors would we look at in that case?
Well, instead of, square footage in bedrooms, we'd be considering things like interest rates, company earnings, even like market sentiment, like how people are feeling about the market overall by analyzing historical data. Linear regression can help us understand how all those factors have influenced stock prices in the past and potentially, predict what might happen in the future.
That sounds like a pretty valuable tool for investors trying to figure out, the stock market. It's so complicated. Are there other fields that use linear regression?
Oh, absolutely. It's widely used in healthcare, for example. Researchers might use it to study, the connection between lifestyle choices and health outcomes, helping us understand the impact of like diet, exercise, or even stress on our overall well-being.
So we could like use linear regression to find the best fit line between our habits and our health. That's pretty wild.
Exactly. And those insights can then be used to create personalized recommendations or interventions, giving people the information they need to make smarter choices about their health.
Okay, finance, healthcare. Where else does this tool pop up?
Honestly, it's practically everywhere. Like marketing uses it to understand consumer behavior and, target those ad campaigns more effectively. Sports analytics uses it to evaluate player performance and come up with better strategies. Environmental science uses it to model things like climate change and predict its impact. The list just goes on and on.
Wow. It's amazing to think that something as like seemingly simple as, finding a line can have such a big impact on so many different areas.
It really shows you the power of math, to help us understand those hidden patterns in our world. And, as we create more and more data, linear regression is going to become even more important as a way to make sense of it all.
I'm definitely walking away from this with like a whole new respect for linear regression. It's fascinating how it helps us understand the world around us, make predictions and ultimately make smarter choices.
It's been great chatting with you about it. Hopefully, you'll never look at a line the same way again.